Welcome, everyone. We are here to introduce you to our spin-off of our project. We are Team Munich from the project program. I am Matias Brezina. She is Kristina Poliakova. And our title of our project is Navigating Your Project to the Future of iGEM. Using artificial intelligence, we present you iGEM Data Explorer. But first, let's make an introduction. We are living the age of information. Information is everywhere. Since we invented the internet, we are interconnected with the whole world. We have a lot of information, and because of that, there are some kind of limitations. It's all the time more difficult to find more and more information. There are some noise and some problems that are also happening in biology. As we expand our knowledge, biology includes a lot of more information, and it's difficult to find. This data retrieval was one of the biggest problems of the humanity. In 2024, there were 2 Nobel Prizes that were given to the biology community. Even though there is physics and chemistry, but the majority of the people in this picture are biologists. And they are given the award for foundational advance in artificial intelligence and machine learning. So what was the main point of all of this? Basically, machine learning and artificial intelligence is creating data correlation between a whole huge of data and try to relate to features and in different ways, so it's possible to understand it in a better way. So what if we use all the data of iGEM, the heart of scientific biology, and trying to transform the community?
So thank you, Matias, for a nice introduction. So, well, imagine you're a new 2025 iGEM team. You have come up with an idea, but the first problem you can encounter, you're not sure if someone has already explored it or not. So what you can do now is manually go through all of the existing wiki pages and try to find the information yourself, which will take a lot of time. So here we present our solution to this, which is iGEM Data Explorer. In one sentence, it's like a ChatGPT, but for iGEM community. So how does it work? So in response to a user query, we retrieve the most relevant scientific information from across all of the wikis and enrich the prompt, the user query, with derived information. This way, the questions can be answered in most precise and efficient way. So here, for example, you can see an example of querying our chatbot. And for example, you can ask questions like which team used that protein and what was the outcome, what were the results, and it will answer like all of the questions. So a little bit to our architecture. So first, we scraped all of the wikis of year 2019, just as a proof of our concept. The data scraped was then chunked into chunks of specific size, and then all of the chunks got translated, firstly got summarized and cleaned using summarization model, and then finally they got translated into its vector representation using embedding model. So practically all of the data points are then stored in our vector store. And once a user provides a query, the query gets translated into its numerical representation automatically. And this way we can compare the query to all of the existing data points stored in our vector store. This concept is called semantic search. Practically, that's the core concept of our architecture. So the data derived and then is being then fed into a large language model to enrich the prompt and answer the question in most precise way. So here, closer look to our data management system. Here you can see our vector store and just one point of data, which contains the text, which humans can read, and as well as a vector representation of this to enable semantic search. Also, we enriched each of the data points with data from Project Phoenix. For example, the medal ones, location, awards, and abstracts of each of the chunks of data of teams. So practically, we also have done a lot of benchmarking and evaluation experiments where we adopted the method called LLM as a judge. So practically, LLM is then giving a text, and based on the text, it creates an answer, which is then our software prompted with. The question, the answer we get is then assigned a score. And here in the graph, you can see average relation scores for varying settings. So what we vary? We vary chunk sizes and embedding models, which translate the text into its numerical representation. So that way, we choose the best chunk sizes and embedding models to go to production. Yes. So our project has a lot of potential to expand. The first thing we would do is not to restrict ourselves to just 1 year, to 2019, but scrape all of the wikis across all of the teams and years and store that in our vector store. The second thing we want to do is advance our filtering and integrate metadata filtering on top of the semantic search. Also, we can improve the way we scrape data and clean it for our database to be more precise and better. Yeah, thank you for your attention.
You can find us in the R10, in the Foundational Advanced Village. Here there is a QR code, so you can also try it yourself. We have hosted a little server with a chatbot, so you can ask questions if the thing works. But even though the QR code is also based in our poster, so you can get it. Maybe if we go back and forth.
But you should definitely try to try it.
We have some time, so why don't we do a live demo?